Greetings and welcome at the Star System. This is episode 2 of my series Inside the Solar System. In this episode I will tell more about the Sun, so let's get started. The Sun lies in the center of our solar system. It keeps everything in the solar system in its proper orbit around the Sun. Some basic facts about the Sun is it is 4.6 billion years old, approximately. One day takes 25.4 days on Earth to complete. The diameter of the Sun is 109 times Earth's diameter. And the mass of the Sun is 332,900 times the Earth's mass, which is huge. Now, the temperature on the surface is 5,500 degrees Celsius. So, the Sun is huge, and why can you say that? Well, it contains 99.8% of the mass of the whole solar system. So it kind of dominates the solar system. Some other things, well, the Sun is a ball of gas, and a ball of gas, when that rotates, it doesn't rotate in one whole object. So on the equator, one day takes 25 days on Earth. But on the poles, one day is way slower and it takes 35 days to complete. Well, 35 Earth days. Now, a little bit of the history and future of the Sun. Well, the Sun is 4.6 billion years old. It is created out of a huge pile of gas. That pile of gas imploded and formed the Sun. By the forming of the Sun, also the solar system was created, so that was a pile of gas that was rotating around the young Sun, and in that pile of gas small objects began to form, which later were the planets, meteors, dwarf planets, and all those things. Now, the future of the Sun isn't really peaceful. We still have 5 billion years to go, so it won't be in the near future. But when the Sun dies, it first will grow into a red dwarf. So it will be way bigger than it is now. When it has consumed almost all of its fuel, it will implode into a white dwarf, and that's the end of our Sun. Now, the light that we see comes from the Sun, obviously. Now, it is formed in the core of the Sun. So there are 3 main regions in the Sun. You have the core, the radiation zone, and the convection zone. In that order. So the core is in the middle, then you have the radiation zone, and finally you got the convection zone. The Sun consists of 74% hydrogen, 25% helium, and 1% other elements. Now, in the core, there happens core fusion. Multiple hydrogen atoms fuse into helium atoms. And by that process, a lot of energy comes free. So really a lot. Well, in 1 second, the Sun consumes 4 tons of matter, and it transforms it into energy. Now that energy, to reach the surface of the Sun, it takes thousands and thousands until millions of years to go from the core, where it has been born, to go to the surface of the Sun. Because in the core there is so much energy, it is very hot. In fact, it is 13.5 million degrees Celsius. Now, when you go to the surface, it will be less warm. Then it's just 5,500 degrees. And then you enter the atmosphere of the Sun. Then you get at the photosphere. So the photosphere is the surface. Then you enter the chromosphere. So the chromosphere is the atmosphere, a part of the atmosphere, where it is somewhat of 2,000 kilometers thick, and it is 100,000 degrees at the atmosphere. Now then you reach a transforming part of the atmosphere where the temperatures rise until 1 million degrees Celsius. And then you enter the corona. The corona can be seen on Earth when there is a full solar eclipse. And there the temperatures go way higher, then you reach multiple millions degrees. Now, the magnetic field of the Sun. The magnetic field is important for the safety of our solar system. It is very, very huge and very, very strong, because the Sun is such a huge, consists of such a huge part of the solar system. It has a very strong magnetic field. Because it is almost all plasma, so almost charged ions, it creates its own magnetic field. It is, as I said, very huge. It goes far beyond Pluto and the Kuiper belt. And this magnetic field creates some of the more interesting phenomena on the Sun. So, because the Sun rotates, the field gets turned and reformed. So, by that you create things that are known as solar spots and solar flames. Spots are cool areas on the surface of the Sun, where instead of 5,500 degrees, it is 4,500 degrees, so a difference of 1,000 degrees average. So those are cool spots. Now the solar flames are, you can say, huge explosions of energy that are thrown into the into outer space. And when these energy flames, the solar flames reach Earth, then it can cause a lot of trouble it can cause electronic faults on Earth's atmosphere and in spacecrafts. Now, one final thing are solar eclipses. These are very beautiful things to see, and what basically happens is the moon is at the perfect distance to block the entire Sun. So then when that happens, the moon goes between the Earth and the Sun and it blocks away the Sun, so you can see the corona. It's something very beautiful to see. So that's it for today's video. I hope you enjoyed it, and I'll see you in the next video where I will talk more about Mercury.